So actually, I cannot wait to tell you more about this three-in-one RAG system, which is really a powerful approach that combines three main methods of retrieval-augmented generation called adaptive, corrective, and self, uh, which is actually optimize our AI assistant or our LLM application. So today I am going to explain these concepts and how to build something called LangGraph and an LLM application or AI agent in very simple words. I will explain the whole papers of these concepts in simple terms. Actually, the LangChain community has provided this code and the concepts and they combine together. So I wanted to do the same thing, but explaining this idea in this whiteboard with many terms and simple ideas about it, with the codes, of course. So let me start with adaptive RAG, the first idea of our RAG, which is actually like a routing system. It checks if it's related to the index or if it is not. And based on the decision, it will direct us to either retrieval, which is the main idea of RAG, or to other tools like search web, for example, to get the answer. So if we go to the paper, we can see the main concept of this adaptive RAG, which is an approach that can select the most suitable strategy, ranging from iterative to single to even no retrieval at all, as we will implement today, like web search. It depends on a classifier, which is a language model that's trying to assess query complexity. For simplicity and more powerful in the same manner, we will use large language model like GPT or Llama, and we will provide a prompt to decide either this is related to the index or not related to the index, and based on that decision we will act. Okay, so adaptive RAG paper has proved that the framework provides like a balance between retrieval-augmented solution and real-world queries by reducing the computational waste and applying also the most suitable model. Okay, the second approach is called corrective RAG, and this corrective RAG is actually proposed to enhance the retrieval-augmented generation or the AI agent by also doing like grading system from the retrieval. So once the routing see this, okay, related to the index, now we will use the retrieval, the vector store to get the answers. But we will do something called grade documents. And these grade documents will check if this document is relevant or not. And based on that, either it will go to the LLM to generate the answer, or it again will go to the web search. So the corrective RAG paper actually proposed something called lightweight retrieval evaluator, and it assesses the overall quality of the retrieved documents, and based on that it provides like a confidence degree. And also today we're gonna use LLM model and with prompts to give us these grades, and the grader will like be a binary, so yes or no, and based on this it will direct us. So this is simply a corrective RAG. And then we also will combine a third method called self-RAG. And self-RAG actually is important in the generation part. So after we generate this part, does the generation answer or the generated answer hallucinate or not? If it has hallucinates, so we need to do something else. Either we regenerate the answer or we will find a solution for it. If it is not, then this is the answer for the user. So self-RAG improves language model responses and by selectively retrieving information based on the model's assessment. Okay, and this, if the main concept of the self-RAG, they produce something called reflection tokens. So it is dynamically evaluate and adjust the quality and the responses. Okay, and it has actually like classification and many types of answers or of evaluation. But for today, we are gonna use like LLM model with prompt again to give us a binary score, yes or no, and based on this, it will generate the answer or regenerate the answer. We will see all these concepts and how they are implemented in the code and combined together. But when we combine these together, now we will see something like this. The first algorithm with the second one. Okay, the second one, if it's like related to index, or if not, it will go to do like web search. And also it will combine the third method by this. And this is actually, we will call it LangGraph. LangGraph is like LangChain, but it is an extension of LangChain. And it's called LangGraph for several reasons that I will explain later. But let's understand what's LangGraph. So LangGraph is a powerful tool for building stateful multi-actor application with large language models. So it's introduced the ability to add cycles, enabling more complex, like we can see now three in one RAG, agent-like behaviors where you can call an LM in a loop, okay, and asking it what action to take next. So the retrieval, the action next is grader. It will decide either the action will be generate or it will be web search. And also like many nodes here, we can see these actions done in like one to the other. So it's like LangGraph. But the key concept behind LangGraph is three things. The first one is the stateful graph. Okay, so it's represent like each step maintaining a state that it's updated and passed around as the progress goes. And we have the nodes here, like the grader, the retriever, and they are the foundation of LangGraph. So we represent the functions, the computation steps, okay, which define to perform specific task. And we have the edges, and these edges, it might be conditional edges based on some condition, and based on the answer, it will direct us to other nodes, and it's define the whole computational flow of this LangGraph. So these are the main or the key concept of LangGraph, and actually combining these together lead us what we see or what we call LLM application. And this is now the whole system where we have the user asking question. It goes to like full prompt and trying to get the answer from the retrieval, the different sources that we have of the data, and it passes to the model or LLM to generate that answer to the user. And this is what we call it like LLM application, which integrates all these strategies together with the large language model to improve the accuracy, the response from the LM based on our data. Okay, so we call it also AI agents. So the agents, when we say AI agents, so it's responsible for three things: planning, which is breaking down the task into sub goals, and memory, which is we have short like chat history, we have long like vector store, and tool use. It might use web search, it might use some functions to do mathematical equations or other tools. So these are the three concepts or three main ideas of agents. Okay, but how? So, okay, before I complete with the agent, so we know the rule of LLM here to generate that responses based on the context and the prompts that we provide. So how these three things are implemented in our Lang chain, or sorry, LangGraph. So we have these both, the AI agent and LangGraph, as planning. Okay, how it lay out a control flow ahead of time, as we can see the control flow and how we control each nodes by the edge. So this is the planning. And then we have the memory, which is used the graph state to persist the relevant information like the documents and questions. And we have tools. And this tool are each node. Each node here, the retrieval, the grader, the web searcher, the generator are the nodes of our RAG. So these are the three concepts of AI agent implemented in LangGraph. So here, as we can see now, we have three in one RAG. Before I go to the code or the whole code of this implementation, I will explain each part of the code so we can understand how they are implemented when we will see the whole code. Starting from the end, I like to start from the end so we can understand better how they will be. We have a workflow of the LangGraph, and this workflow tells us the age, the nodes that we have, and the states, and how we gonna go beyond or ahead of the time, as we say, the control flow. So starting from the conditional entry point, which is the router. Okay, so this is the first step, which is the router, the adaptive RAG. And this is either will go to the retrieve or the web search. Okay, so I will define this, the retrieve or the web search. Then I will add age. This age will do like the grade documents with the retrieve. Okay, and based on this generation decided to generate, it will go to generate or web search. And what about this second workflow? It is, yeah, the corrective RAG. So either it will generate or web search based on the grade and retrieve. Okay, and then the third thing is, okay, we add the generate and web search, and now we have conditional edge. The conditional edge like generates. So, and the generate, it will tell, okay, either we not supported, so generate, or useful. So we got the answer end, or not useful, and we will do the web search. So this is generates. Okay, this is useful, and this is not useful. So this is our workflow for this implementation. And these are this is the class of the graph state, which is the nodes, the conditional age, and we then define the workflow with defining the nodes. So we have the node, okay, we have retrieve, we have the generate, we have grade, we have web search, and we have some conditions which do the grader or to decide either to generate or not. And after generation, it will decide, okay, if it is useful or not. So this is the conditional edge. And this is our Lang graph in general. So let's start explaining each of these concepts and how we implement. So how we implement the adaptive RAG, which does the routing thing. So I will use LLM model, and after some minutes, I will show you the code and the element that I will use. And actually, there is a surprise because I am not going to do like using some GPT models that take the API and it will cost us some, or I will not go to use some downloading some models. No, you will see. But here, the main concept, which is the prompt templates, which is begin of text, and we have like start, header ID. All these tokens are important for identifying the system, but we are going to tell this adaptive RAG, you are an expert at routing a user questions to a vector, store, or web search, and we will give the whole things about it. So because our data will be like about prompt engineering, LM agents, So, okay, use this for questions on LM agents, prompt engineering, attacks, and you will do this within these keywords. Okay, so if it's related, okay, if it is not related, we will do the web search, and it is like a binary choice. Okay, it is a binary choice, either web search or vector store, and we complete this prompt template. Okay, we will create our agent now, or the router, which is take the prompt, the LM, and to the parser to generate the outputs. Okay, and here, like I am doing some example that I will show later. Now we need also for the corrective RAG, and also we are using LLM. But this time the prompt is different. We are telling them to grade the document. So either do something like grade assisting relevance of a retrieved document to a user question. And if the document contains keywords related to the user questions, grade it as relevant. Okay. Then if it is not, so we will do something else. So this binary score is yes or no, as we can see in the graph. And based on that, it will behave. And it will take what? The question and the document. So we have the vector store that will bring the document that got the answer from. And we will have our question. And based on that, we will do the grading thing. If you notice here, we only taken the question. So here, the question is to see if it is, okay, related or not. Here, we are going to take the document, the retrieval one, and the question. What about the self-RAG? The self-RAG, we will take the generation, okay, the answer and the documents, okay, and based on that, we will grade. So also we'll use an LLM. We will do like this prompt total, and it also will provide like a binary score. And okay, here is like a JSON format. We will tell, okay, this document and this is the generation. We have the parser. Okay, get me the answer. So these are simply, and here we have the example. Okay, so this is simply how they are implemented. And as we can see, it's all depends on prompt engineering and LLM. And using LLM in adaptive RAG, corrective RAG, and self-RAG, and then add the generation part, which is here. This is very costly if you are going to use like closed source models like GPT 3.54 or GPT 4. But this time, because we are using all these, we need like a really good, powerful large language model, and it will be like open source model. So for today, I am going to use Llama 3, which is the latest LLM that came to the market. And for making it like local AI agents, we're gonna use Llama 3 from Olama. So we have this Olama where we can do the local Llama. We will see the code. But before moving to the code, we have two more codes here to explain. So we can combine all these codes together in our AI agent, which is the vector store. The vector store simply will take some documents regardless of the sources of the data. So it might be PDF, it might be URL, and I am going to use like web-based loader to load all this into docs. And then we will generate like a list, and we'll split this to splitter, so we can use like TikToken to split, and we will define our chunk size, and we will have the doc splitted. We will use the vector store like Chroma to convert all these to embeddings, and we can use also GPT for all embeddings, which is a free embeddings model. We can use it, so also we can download it locally. So we will perform the whole AI agent in a local on my laptop. So here we have the retrieval, and our vector store is completed now. For the generator also, we will generate the answer. So we will take the question and the documents, and now we have the prompt and LM, and we will ask the model to retrieve like agent memory to tell me more about it by taking this this prompt, like taking the question, the context, and will give me the answer. Also, the web search, there are many tools to use, but I like to use Tably. We can import it easily. We can use it like this. It requires API. It's first give you like a free 1000 request, and it is efficient actually for now. So this is the whole code, and this is all we need to implement our 3-in-1 RAG. So now let's move to the code. So here we go. This is our code. This is our LangGraph, the 3-in-1 RAG, and make sure you have all these. So we can get, like example here, to get the embedding models. We need, of course, the LangChain to community, take token for the splitting part, as we saw, ChromaDB to convert, LangGraph, this one for the web search. So make sure you have everything. You can use OLLAMA to pull Llama 3 in your local machine. As you can see here, I am using like localhost. And then the first step to do is to choose our, because OLLAMA provides like Llama 3, Llama 2, Mistral, Gema by Google. So they have some open source model, and it is really nice to do all these concepts in local. So this is my local LLM for today, LLM3, the latest LLM. And I am going to load some environment because I have secret keys behind. It is only one actually. I am using like the web search. That's all what I need. And here, as we saw previously, this is the 3 URLs that I am going to do today, the question answering part, like agents, prompt engineering, and some about the attacks. So all these will be converted and splitted using ChromaDB, and also the embedding model will be GPT-4 for all embeddings. So here I start loading, splitting, chunking, all these concepts together. And it's okay, now it's done. I am moving to the grader. Okay, and I explained already. So I will ask about agent memory, and we will see what it will retrieve. So this will do the grader retrieval, and it will tell if, so we will wait the answer. So it will take the question and the document. So we need to see, okay, yes. So, okay, since we are asking about agent memory and one of the documents about agent, so it will retrieve, yes, this is the retrieval between the question and the documents. Great. Also, yes, I am using the first document here, so you can manage this. The generate, now we want to generate the answer, okay? So we will use this. And yes, here we are using our local LM. So we will have to import this chat OLLAMA, and we will use our local LM that we defined, Llama 3. And now we have the prompt here to generate me the answer. So it will take the question and the context from the retrieval, and it will give me the answer. So I am going to ask about agent memory. So I will do some, I have to run this. And wait for the answer to come up. Okay, while waiting, okay, here we go. So the context mentions that the memory component of LLM-powered autonomous agent system includes a long-term memory module. Okay, and it gives me actually a complete answer for our agent memory. And yes, since it's yes, so we can retrieve and we can get the answers here by the Llama 3. And here we can see the hallucination part. Okay, if it's doing the grader, which is self-frag. So I will run it. I explained already the prompt and how they are implemented, and also I am using the local LM, which is Llama 3. So this is, it will give like me binary score, yes or no. So as we can see, we can also decide, because it's talk about the agent memory, and it say yes. So the score was yes. Okay. Here we will grade the answer. Okay. Of course, also I am going to use Llama 3 or the whole concept, the prompt I have previously checked. Okay. So we got yes. So it's between the question and the generation. This is great. Now we have the router. Did you remember now? Now let's implement the router, the first concept. So I am putting all together, as you can see. I start with a simple example. I see if it is relevant or not, hallucinate or not. Also, I generated the answer. So you can see, guys. Now we can rearrange this so we can start from, of course, the routing, then the corrective and the self rag. But now I want to show you how it does the routing based on that prompt and our local LLM. So now I am going to ask about LLM agent memory, and I want to see if it's, remember, it is like, it will give me web search or retrieve. Okay, now, okay, that store, vector store. This is great now. Okay, here we can use the search in case we need it later. Okay, so we will see. So these, the whole concept together. But as you can see, it is not in order because as we agreed, we have routing, then we need to do the corrective rag and we will do the self rag. So now we will define our LangGraph. Okay. So we will do like the graph state that I explained already, okay, which take the question, the generation, or the web search, and the documents. And here we go. We start with the retrieve. These are my nodes. We have the generate, we have the grader doing the grade. And remember, we are calling all the functions that we have defined previously and doing some invoking for the grade and writing, printing some yes, no, document relevant. We're going to see all this and and it's provided with the explanation. So nothing new here. Then we have the web search, of course, and the conditional edges. Now, for the conditional edge, we have first the routing, right? The routing one. Then we have to decide either to generate or not, and we will evaluate our answer or the generated answer by the LLM. And now we have the workflow. Our workflow involved the web search, the retrieval, the grader, and the generator as we agreed. Okay, so let's run this and make sure all is okay. This is fine now. Now we have our workflow built. So as I explained, this was the first thing I explained in our in my whiteboard. I start from the end, and which is the graph build. So we will do the route first of all, then we will do the condition, the corrective rag, and then I will do the self rag. So this is my workflow. Now I need to test this. So I will compile my workflow and I will ask about what are the types of agent memory. The second questions will be who are the peers expected to draft first in the NFL draft. So yeah, this is not from the sources. So I wanted to like to do the web search and let's see here how, okay, it routes to the vector store and here it will retrieve or it will go to the web search. So let's see this. So first we combine, we see the route question, what are the types of agent memory? Then it's decide to be a vector store, it will route the question to RAG, so we will retrieve. Retrieving involving checking the documents and it gives like grade, and this is normal here because it shows like Llama cannot because this, so we will do it again until it works with us. So no problem with this error. Okay, so again, now it decided to do, okay, the grading thing. It's grade the document now. It will grade each document in our vector store. And now it's decide to generate. So it will generate the answer. Hopefully it will go to the LM and it can be generated Yes, now, okay, it will check the hallucinations. So this is nice. This is self-RAG now. Okay, decision. It makes the decision now. Generation is grounded. And here we go. Finish training. We have the generated output now. So, what are the types of agent memory? We have the sensory memory. We have the maximum inner product search. We have other things. These are the types of our agent memory. So this is great. What about the second questions here? It's with route now, and of course, it will be like web search, right? Yeah. So this is the decision. It will be web search. The whole routing now done, and will generate. So based on the web search, it will generate the answer for us. So all questions are answered now. Yeah. Now the answers is here. So, of course, it might be in the same topic, but it is not in our documents. So we can perform like web search to get the answer. So all the questions we ask or the user ask, it will be answered by correct answers, either based on our data or it's based on web search. So this is great. And this is this is the application that I really found useful, and I wanted to explain by myself uh, and provide it to you so you can understand more about how we use local llama or local LM in general using OLAMA, how to make three in one RAG using the three amazing concepts of adaptive RAG, corrective RAG, and self RAG. And that was all for today. Thank you for watching and hope you found this useful.